The moon. This giant rock floating around in the empty void of space around 242,000 miles away is always a beauty to behold in the night sky. But it wasn't until a few decades ago when Neil Armstrong made history by becoming the first human to ever walk on the moon. Ever since then, our interest in the moon has been on the rise. So much so that recently, NASA began a series of missions under their Artemis program. The purpose of Artemis is to establish a long-term human presence on the moon. This will be a major stepping stone in our plans to spread our civilization to Mars and eventually other planets out there. Aside from the scientific progress that Artemis aims to bestow upon us, lunar exploration has a massive potential to grow our economy in so many ways. The Artemis program has 3 phases to its mission. Phase 1 oversaw the successful unmanned launch of the Orion spacecraft and Space Launch System around the moon. The upcoming Phase 2 will be a manned launch of the Space Launch System and Orion spacecraft around the moon. By Phase 3, NASA hopes to have regularly scheduled Artemis missions with an established human presence on as well as around the moon. It plans to do this by building a lunar base on the south pole of the moon by the end of the 2020s. Since Artemis will be our first attempt in decades to put feet on the moon, this means new technologies must be produced to facilitate the mission. The spacecraft that will be transferring the crew, the spacesuits that will be worn on the lunar surface, the creation of the orbit outpost called the Gateway, on-orbit fuel transfers, and the habitat for the lunar base are all components of Project Artemis that NASA either has or will potentially task private companies with through multi-billion-dollar contracts. For example, NASA signed contracts with private space companies Blue Origins and SpaceX worth $6.3 billion collectively for the development of the Human Landing System, which will transport astronauts between the lunar surface and the orbiting Gateway station. This not only saves billions in taxpayer money, but will lead to the creation of tens of thousands of new jobs in what is the booming private space industry to design, construct, and test this system and then implement it on the moon. It gets even better. Should Project Artemis be a success, then lunar tourism and payload delivery could be a huge source of revenue as well. While exact estimates can't be made yet, NASA predicts anywhere from several million to well over $1 billion in economic activity could result from this. And with improvements in the lift capability of rockets, the transport cost per kilogram of payload has been reduced drastically, which will also fuel the development of new sectors of the lunar exploration industry, like nanosatellites and constellations of communication satellites. Above all this, there is another economic reason worth looking into the moon for: an isotope called Helium-3. Now, if you want to learn about the science of Helium-3, as well as why the moon has a lot, and some of the technologies and processes that can be used to extract the Helium-3, then be sure to check out our Helium-3 series. Assuming you've done that, let's take a look at the economics of Helium-3. The moon is estimated to contain around 1 million tons of Helium-3, and calculations state that around 25 tons alone can power the United States for a year. Constructing a Helium-3 fusion power plant to actually utilize the energy from the isotope would take around $5 billion, and each shipment of Helium-3 to the Earth following its extraction from the moon would cost around $140 million for roughly 220 pounds of Helium-3. That's not even factoring in the cost of building heavy lift boosters, as well as lunar mining facilities to extract and ship the Helium-3 from the moon to the Earth. It is estimated we can extract around 145 pounds of Helium-3 per year with one miner processor, which is 2/3 the amount needed for a 1,000 megawatt fusion power plant. As a result, it would take anywhere from 5 to 15 miner processors in order to extract a meaningful amount. With 5 of those 1,000 megawatt fusion plants, electricity could be supplied for as low as 5 cents per kilowatt hour. For comparison, in 2022, the average US household paid around 15 cents per kilowatt hour for electricity. Not to mention, a Helium-3 power plant would be far cleaner for the environment compared to coal, and the extraction and transport process would not be as detrimental to the environment as natural gas. Overall, both Helium-3 lunar mining and Artemis aren't something that will be built in a day. There are still a lot of obstacles along the way to make both of these things feasible and a massive part of our economy. This video was meant to introduce you to these concepts, and there will be more to come as developments are made. If you wish to keep up with Project Artemis and Helium-3, as well as a bunch of other developments in science and technology, then stay tuned for future Artemis videos, as well as upcoming installments in our Helium-3 series. As always, we hope you enjoyed this lesson, and stay tuned for more science videos.